Okay, this is target 1D on symmetry, and we're only looking for symmetry over the y-axis or the origin. These are given to be functions, so it says it's a function. If it's a function, that means it cannot be symmetric over the x-axis. So we're only looking for either the y-axis or the origin. So remember, for y-axis, you let x equal negative x. So you replace x with negative x. So I'm going to replace x here with negative x, and I get f of x, or y if I want it, equals negative x to the 12th over negative x minus 16. Now negative x to the 12th turns into positive x to the 12th, but this says is negative x minus 16. Now I look at these two. Are these identical to each other? And the answer is no. There's a negative here, and there isn't one here. So this means it's not symmetric over y, or not symmetric in the y-axis. Like I said when I was learning, it was over, now it's in. The thing to be careful with is if you're graphing these on Desmos and looking at them, this one looks like it is symmetric over the y-axis, but if you look closer, they won't line up equally. The two y values are different when you have, the two x values are different. When you have the same x, it's a little different. Okay? Alright, now we got to check for the origin. So I'm going to do that in blue. So for the origin, I replace x with negative x and y with negative y. So this is really y equals, so I'm going to replace that with negative y equals, and again x with the negative, so negative x to the 12th over negative x minus 16. And I'm going to leave the negative y for the time being, and I get positive x to the 12th over x minus 16. Negative x minus 16. That stays a negative. The negative x to the 12th turns positive. Now to fix this, I'm going to multiply by a negative 1 over 1. I'm going to use a different color. So I'm multiplying by negative 1 over 1. So I get y equals negative x to the 12th over negative x minus 16. Now remember, I'm multiplying negative 1 over 1, so only the top gets multiplied by the negative, not the bottom. Okay, now I have a negative here and a negative here, so maybe I should see if I can factor out a negative at the bottom, and then these negatives might cancel. So if I did that, I'd have y equals negative x to the 12th over negative x plus 16. And sure enough, I factor out the negative, so this becomes positive and this becomes positive. These negatives will cancel, and I'm left with x to the 12th over x plus 16. So I guess I should have looked at this. Are these equal? And they're not, because this has, wrong one. Are these equal? And they're not. This is a negative x to the 12th, and this is a positive x to the 12th. But I should also now look and see if, now that I factored out the negative, if that's equal. And this is positive x to the 12th, so it's looking promising, but on the bottom, I have an x minus 16, and here I have an x plus 16, so they're not equal. So this is not symmetric in or about the origin. Okay, so let's look at the next problem. So for the next problem, I'm again looking for the y-axis and the origin. So for the y-axis, I'm going to replace x with negative x. So I get y equals negative x to the 9th over negative x to the 6th minus 15. And I get y equals negative x to the 9th over x to the 6th minus 15. And these are not equal. So this is not symmetric. Symmetric in y. So now let's check the origin. So for the origin, remember I replace x with negative x and y with negative y. So I have negative y equals negative x to the 9th over negative x to the 6th minus 15. Now when I plug that in, I get negative y equals negative x to the 9th over positive x to the 6th minus 15. And then again, let me grab another color. I need to multiply by negative 1 over 1. And I get positive y equals positive x to the 9th over x to the 6th minus 15. And look at this. Those are equal. So that means it is symmetric in the y-axis. Okay, and we have one more practice problem. So here it is. So we want to check to see if this is symmetric over the over y. So I'm going to let x equal negative x. I'm not going to write it down, I'm just going to do it. So I have y equals negative x raised to the 12th minus 13, and that's in absolute values. So I get y is x to the 12th minus 13. And when you look at that, those are equal. So this is symmetric in the y-axis. Have another color. And now to check the origin. I get negative y equals negative x to the 12th minus 13. So I have negative y equals x to the 12th minus 13. And then I'm going to multiply by the negative 1. And I get y equals negative x to the 12th minus 13. Now these absolute value lines or walls, don't let anything in. So you cannot distribute through. So you can't distribute that negative through. So this is the way it has to remain. So if I look at that, obviously the x to the 12th minus 13 is similar, but this has a negative and this one does not. So this is not symmetric in the origin. Okay, so now we have 3 practice problems. So remember, you have to show these practice problems to either math lab teacher or myself. And once you've demonstrated that you know how to do these problems, you can do the retake. Okay, so here's the first one. You have to determine if this is symmetric either over the y-axis or the origin, not the x. And the same thing with number 2. You have to determine whether this is symmetric either over the origin or the y-axis. And the last problem, number 3, you need to decide if this is symmetric either over the origin or over the y-axis. Okay, good luck.